Hello everyone, thank you so much for joining after break. We have wonderful papers lined up in this session, which is on how people experience security and privacy. And it's my honor that there are SOK works in this session, as well as replication work, and of course, new studies and so on, right? So excited about all of them. We have speakers from everywhere. It's a very diverse group, so very excited about it. So let's invite our first speaker, whose work is on replication study, a study on how users don't use password managers. And Pithayuth is the fifth-year PhD candidate at University of Southern California. He expects to graduate this year, so he is in the job market, and I'm quite sure we would have questions, interactions post this interaction. So yeah, over to you.
Thank you for the nice introduction, and yeah. Okay, hi everyone, my name is Pithayuth Charnsethikul. Today I'm excited to present our paper, Replication, a study on how users don't use password manager. This is a joint work with my amazing co-author at USC, Anushka, Dipsy, Gale, and my advisor, Jelena, Mirkovic. As the title suggests, our paper is a replication study. The original study by Mayer and his team was conducted at George Washington University in 2021. And the study quantified user password habit and password manager usage within the university population. The study used an online survey where its questionnaire was derived from qualitative study by Pierman and her team in 2019. Specifically, Pierman conducted an interview to study user password manager usage and motivation. So in other words, this original study was the first large-scale quantitative study measuring password usage within an institution. So for our study, we replicate the study by Mayer and his team at USC in 2025. So our motivation is threefold. First, the replication allows us to test whether the original finding generalized across university. Secondly, the replication allows us to evaluate the change over time. And lastly, and most importantly, the replication allows us to verify the claim made in the original study that users were likely to adopt the free third-party password manager if offered by the university. So despite this positive result that the original study claimed that users are interested to adopt the free password manager, George Washington University ultimately did not purchase the third-party password manager license for some reasons. However, at USC, we do provide a free third-party password manager, 1Password, that make us not only can directly verify the claim, but also study additionally whether users actually adopt the free password manager. So to summarize our contribution, in addition to verifying the original finding, we also conducted this following analysis. First, we measure the extent to which users adopt different password strategies, and then we measure the extent of password reuse per user. We measure the awareness and actual usage of the free password manager, and we analyze the differences in password practice among faculty, staff, and students. As a replication study, we share very similar methodology as the original study. We use an online survey with 437 university participants. We reuse the questions and from the original study with some addition and modification to capture more insight that were not covered in the original finding. We use the same incentive as the original study, which is the $10 gift card, or we basically select one winner for every 10 participants, and the study is approved at exam by our IRB. So let's look at the result. So at USC, only 4% of our participants were unaware of password manager, comparing to 9% at George Washington University. This suggests that most users now are aware of password manager. And to measure which password management strategy user use, we provided slider for participants to select percentage of password stored in each password strategy. A positive percentage for a strategy indicate that the participant used that strategy, whereas at George Washington University, the original finding provide a multiple choice question that user can select all password strategy they recall using. So our results show that 94% of our participants now are password manager user, comparing to 77% password manager reported in the original study. We interpret our result as a gradual increase in password management usage over time, since our study was conducted 4 years after the original finding. Out of these 94% that are password manager user, 76% of them are using multiple password manager type. For example, these are those users who use password manager on both their phone as well as their browser. Not only that we measure which password strategy user employ, we also measure to what extent user use each password strategy, which is not covered in the original finding. We find that users still rely on their memory most to manage their password. Specifically, users remember on average 50% of their password while using a browser password manager to manage on average 40% of their passwords. The most reported password strategy is in this order. First, remembering password. Second, using browser password manager. And third, using system provided password manager. This order is consistent with the original finding at George Washington University. Now, we measure to what extent users reuse their password, which again is not covered in the original finding. We found that on average 40% of each user's password were unique, meaning that more than half of each user password were reused. This suggests that the common password reuse issue is still prevalent today. We break down this password reuse habit across different roles at USC, and we found that faculty has the best password habit, where on average 70% of their password are unique, comparing to students where only 20% of their password were unique, which means students reuse on average 80% of their password, which is quite alarming. To counter password reuse, Password Manager generally offers a strong password generation feature. However, we found a consistent result of low password generation usage similarly to the original finding. Specifically, only 26% of USC participants use the password generation, comparing to 20% at George Washington University. We dive deeper into what extent users use this password generation, which again is not covered in the original finding. And we found that 26% of USC participants use password generation frequently, as it is indicated in the green bar in the figure 5. And 58% use it at least occasionally, as suggested in the combine of green, yellow, and pink bar in figure 5. So this 26% shown in figure 5 match exactly 26% shown in figure 4, meaning that in the first analysis, we underestimate the number of password generation users to just those who use it frequently, whereas in the second analysis, we showed that more than half of users now are actually or have used the password generation. Ideally, the next step we are hoping to see is that this 58% become a regular password generation user and not just using it occasionally. We do provide some suggestion on how to increase this password generation usage in the paper, so highly recommend to check them out. Next, we verify the claim made in the original study that users are likely to adopt the free third-party password manager if offered by the university. And we found that contrary to George Washington University findings, USC participants were unlikely to adopt the free password manager. Specifically, 48% of password manager users at USC were likely to adopt the free password manager, which is significantly lower than 71% reported at George Washington University. And similarly, 26% of non-password manager users at USC were likely to adopt the free password manager, which is again significantly lower than 56% reported at George Washington University. So we dive deeper into the awareness and actual usage over this free password manager, which at USC we offer 1Password. We found that only 35% of participants were aware of this free password manager offer, and the usage is even lower, with only 15% using the free password manager. After learning about this free password manager offer in the study, only 24% of participants expressed interest in adopting it. So these results suggest that even when the university offers a stronger security tool, such as 1Password, which typically costs $35 per year, users still reluctant to switch. In other words, despite the fact that these third-party password manager providing a greater range of security features comparing to traditional OS-based or browser-based password manager, users still feel that switching to this free password manager isn't worth the effort. We provide some suggestions in our paper about increasing this adoption, so again, highly recommend to check it out. And that summarizes my presentation. I'm gonna conclude it with this slide for the takeaway, basically what we have done, which is confirming some of the previous findings that most users now are aware of password manager, and they also use password manager, but again, the security feature like password generation is not widely used. We reviewed the claim in the original finding that users were likely to adopt the free password manager. And we additionally found that the awareness of the free password manager is low and the usage is even lower. So thank you for listening, and I'll be happy to take questions.
Yeah, thank you, Pithayuth. Any questions? While we are warming up to that, it's good to hear that the faculty were the group who use better passwords and managers as well. Given that there were a few differences between GW's study as well as USC, how much do you think the institutional campaigns or user awareness programs has impacted, or do you have any evidence on that?
Yeah, thank you for the question. And yeah, actually, there might be some impact. We discussed it in detail in the paper that right now, currently at USC, we got the result that there is a low awareness of this password manager offer. And one of the reasons may be because we only passively advertise about this offer. And our suggestion in the paper is that we have to be more proactive. Basically, right now, we only advertise this offer through like Slack channel, email, or like through employee training. But maybe this offer or like this highlight of why this password manager is better, and whether you should try it, should be like highlight during those critical moments. Like for example, when someone reset their password, or when there is a breach and someone need an urgency to create the new password or something like that. We can just nudge them toward like this better security tool. But yeah.
Great, thank you.
Yeah, thanks for the great talk. So if I understood it, there's still a lot of the USC students are using the password manager. So now is the issue that it's not that they don't want to adopt this new one, but switching to a new password manager, is that part of the issue that's happening here?
Let me rephrase if I understand your question correctly.
Yes.
So basically, I think in the past USC does provide a free password manager, which is not 1Password, but I think USC has been providing the free password manager for quite some time now, regardless of what that third-party password manager is. But the result that we found in the paper is that the reason of this low adoption of the free password manager is not only the fact that the awareness is low, but also the fact that users feel comfortable with the password strategy they're using and feel that switching to the new or like even the better tool would be not worth the effort. I don't know if that answers your question, but
yeah, thanks.
Great. Thank you again. Let's give a warm round of applause to Pithayuth.
Thank you.
So from password managers, the next topic is on password strength calculator. So Anne, who is a research associate for the research group at Security Usability Society, SecUSO at KIT, is a PhD candidate, and her research interests are in vulnerability disclosure and notification and raising awareness for cybersecurity topics among kids and their parents. So very relevant to our keynote as well. So over to you, Anne.
Perfect. Thank you very much. Oh, it's already there. Perfect. Working seamlessly. Yeah, thank you very much for having me. I'm very happy to present our paper. I found the text to be encouraging, evaluating different password strength calculator designs. And actually, I'm even more happy because this work was done by my student. She did her master thesis on this topic, and unfortunately, she cannot present herself to be here. She cannot be here today and present herself, so I have the pleasure to be here and say something about what she did or what we did in this work. So for, no, wait. I think, I'm sorry, I think it's the, wait. I think it's not using my presentation, right?
Is it the AV or is it?
Okay. Whatever solved it, we solved it. Just a quick motivation about the topic. As you might know, password authentication is still the most common authentication method, but it comes with disadvantages. Users choose weak passwords, or hackers take advantage of simplistic credentials. So there's a need for users to create stronger passwords, but how can we motivate them to do so? Research or literature has shown that, for example, password meters are a good way to motivate users, but also emoji-based feedback, empathy-driven messages, or fear appeals. And that's it has been shown that interactive fear appeals increase password strength, but also fear appeals raise some concerns in the literature. So it has been shown that they are based on weak evidence, they can lead the recipient to make poor decisions, and they could pose unrecognized long-term risks. So we wanted to challenge this claim that fear appeals is the most, the best way to motivate users to choose strong passwords. And that's why we looked at what else can we do to motivate or to make a password strength meter effective. And we found that password strength feedback is important, a visual feedback nudge, something like a color bar or a social comparison can also motivate users, and additional guidance for password creation is recommended. So we stated in total 5 research questions. The first 3 were like, how do different password strength calculator designs differ regarding their effect on the security of users' passwords, so the strength and the length of the password, their emotional impact on the users, and their usability. Our 4th research question was which effect does using positive feedback nudges in password strength calculators have compared to fear appeal nudges? And the 5th is which effect does additional information have compared to not providing additional information and guidance. To answer our research questions, we first designed 6 interactive treatments, which I will show on the next slide, and 1 control treatment, which you can see here on this slide. We used ZXCVBN to calculate the strength and the length of the passwords. And we also used HTML, JavaScript, and CSS to implement the designs. So the treatments looked like this. We had 1 treatment, so we had the control treatment, then we had 1 treatment that only had the colored feedback bar without any guidance. So while the user is typing, they see how the feedback, the color is changing, and depending on the strength of the password. And the next one is the same, so we have the colored feedback bar, but this time with guidance. And the guidance is interactive, so when the user is typing, the check marks change. Then we have the fear appeals treatments. We use the same design as in related work. So one, we have the fear appeals without any guidance, just like the fear treatment. And then we have the fear appeal with interactive guidance. So as you might remember, this is basically the same as I showed you on the first slide. So this was where we took the example from related work. Next, we had 2 treatments with positive feedback, one only showing like a smiley or an emoji, when the user types in the password, and the other one having the emoji-based feedback and as well as recommendations. We designed a user study in Desai survey, so all the treatments were implemented in Desai survey, and we used a between subject design. We did not store any plain text passwords. We only stored the value, so the strength and the length of the password. So in case we advised people that they should not enter a real password, but in case they did so, we would not have their credentials. We just have the value for the strength and the length. We used snowball sampling. All our participants were volunteers. We recruited them via social media and word of mouth. And in total, at the end, we had 89 valid cases who answered our survey. For the results, do we see any differences between the treatment groups? We saw no statistically significant differences for the strength or the length of the password. And also the treatment groups had no effect on the emotional effect of the people. But we saw the significant differences in usability, and specifically post-hoc tests showed that significant differences appear in usability scores between the fear appeals guidance treatment, so the fear appeals with additional information, and the fear appeals with no guidance. We also, as we did not have like a really large sample size, we also did non-parametric tests, which also confirmed these findings. For research question 4 and 5, where we looked for specific differences between the fear appeals designs and the positive feedback designs, we found for the fear appeal and positive feedback, there's no statistically significant difference between password strength, password length, emotional effect, or usability. But interestingly, for the treatments without and with additional guidance, again, we found no statistically significant differences regarding strength, length, or emotional effect, but we found, again, statistically significant differences for usability. Password feedback designs that had the additional information, they were rated more usable. In summary, we designed and compared 6 password strength calculator designs with respect to password strength and length, emotional effect, and usability. We manipulated the design of the treatment or the design of the password strength calculator. We used colored feedback bars, fear appeals, and positive feedback. And we also manipulated the information. So we provided no information and information for the other half of the groups. We conducted a user study with 89 participants. We found in total no significant differences for strength, length, or emotional effect. And we also found no significant differences between treatments with fear appeals and treatments with positive feedback. But usability scores were significantly higher for the additional information and guidance, which is also confirmed by the user feedback. So we had a feedback question in the questionnaire where we said, please briefly tell us how you interacted with the elements below the field where you entered your password. And it was something like, yeah, I checked all the why pop-ups, so they really checked why they should create or why their password is maybe not strong enough. And also they said, oh, I found the text to be encouraging. To conclude, we would say that positive feedback can be a feasible alternative to fear appeals. So if you are not comfortable with using fear appeals in your design, positive feedback is as effective. we found that additional information and guidance increases usability. And the increased usability that we had with the information and guidance does not negatively impact the password strength. And future work, for sure, we would like to conduct a study with a larger sample. So a priori, power analysis showed that we should have at least 300 participants for the ANOVA that we did to compare the different designs. So 89 is probably not enough to detect any significant differences. And we were discussing if maybe a more realistic setting where users are not told that they should create a dummy password, but they should use a real password, maybe this can help to have a more realistic setting for them instead of this lab setting that we had in the survey, where they should imagine to create a password instead of really creating a password. So with this, I would like to end the presentation. Thank you very much for your interest, and you can read the paper or contact us if you have further questions.
Yeah, while we are,
Hi, great work, and I just want to commend you on your bravery because presenting non-statistically significant results is really important. One question that I had is, do you happen to know what the mean was for your variables? Because one of the things that I'm thinking might have happened is that you saw a ceiling effect because passwords and seeing these interventions are something that people see quite often. And so maybe it was a too long didn't read type of thing, and maybe the scores were high overall, and so therefore you didn't see much difference. But I know that your student was supposed to present, so I just was wondering if you remember if the means were generally high overall.
Yeah. So that's exactly a question I can answer. Thank you. Yes. So I think there are two answers to this. First, we had the recruitment strategy, which biased people who are interested in the topic probably choose to participate in our survey. So in general, we saw very long and very strong passwords. It was not we didn't have a comparison, so we did not know if other people would have chosen different passwords, but we saw that passwords in general were very good. So people were probably prompted to create a very strong and very good password. We also asked, we also, as I said, we had this feedback, open text feedback field, and people really said, yeah, I usually use password managers to do this task, for example. So if they choose a less strong password, maybe this was because they are not used to create passwords on their own. So that's why we think, especially with a larger sample and a more diverse sample in terms of what people, where they come from, what background they have, we would probably see a more, a better, not better results, but more grounded results on that.
Awesome.
Yeah.
Thank you.
Welcome.
Okay. Hi. So I had a few questions and suggestions. So let me start with questions. How did you measure usability? Is it something that the user tells you, like I found this score of 5 for usability or something?
No, we used the SUS score, so system usability scale for this.
Okay. Okay, but it's the feedback from the user, right?
Yes,
it's not
yes.
time to create the password or something.
Sorry, I didn't.
It's a feedback from the user rather than measuring how long it took them to create a password. Okay.
Yeah, true.
Okay, so my suggestion was, I think you just ask them to create the password but not to use it for future login, and then I can just type random characters if I'm doing that as a participant. So I would suggest to have this usually people do it after 1 week you have to come and try to log in.
Yeah.
And then, online participation is probably, because your study can be done online, then on Prolific and other platforms, you can recruit people to have more participants. And the last suggestion I had, I'm not sure if what you showed us is exactly what you showed to the user, but if it is, it's too much information and no one reads it. I would go for something shorter. Like if you can give them shorter feedback, it might actually influence more what they do because they can read it.
Yeah. I think maybe two thoughts. So on your second about the how to conduct it, online versus lab study, and that's so exactly we planned for a lab study, but unfortunately ended up with an online survey because of time restrictions. But that would be interesting. Yes, sure. I forgot to tell you that, but having it as a lab study, like people, where we can watch people, like how much time did they need for it, and maybe have...
No, you can measure it. Like doing it in a lab is very restrictive. You cannot have a lot of participants. But if you do it online in your, like if you use Qualtrics measures time that someone takes on a given question, and you can then measure, for example, how quickly they did it, or like how many trials they did.
Yeah, true. And I wanted to comment on the third one, which was, sorry, can you remind me? It was the...
online participation through Prolific, or the last one was just too much information that you gave to the user.
Yeah. So we were thinking about this, and interestingly, my student said, oh, that's too much information. We cannot provide them with all of them. So she really focused on the most, on the advice that was most important for her. And I said, still use it as the original study, so use the amount of information. And I found it interesting that people rated the treatments with the more information better. So at some point, it kind of helped them. If they used it, it was kind of interesting for them to, I think someone said, I watched my password while it changed, and then I clicked all the Y buttons to see what exactly changed that it's now better than it was before. So, I mean, I think it was a setting where people were allowed to try. It was not like, okay, prompt your password and then store it somewhere. So it was, as I said, it was not really realistic in that sense. So this might have helped to have the treatments with the more information rated better. So yeah.
Thank you.
Great. Let's thank Anne again.
Thank you.
And yeah, talking about authentication, so keeping up with the theme, the next talk is on usability study of Duo 2FA. So Dr. Prapti or Renessa recently earned her PhD in computer science at University of California, Irvine. And currently she's a software engineer at Cisco. Congratulations. And her focus is on network security, embedded system security.
So I use this. So yeah, sorry about the quick practice. I haven't seen this before. So, hi everyone. Thank you for giving me the opportunity to present our work, Duolingo, usability study of Duo 2FA. Okay. What? Okay, yeah, this one. Okay. Yeah, sorry for the hiccup. Yeah, so let's start with the motivation behind our work. Multi-factor authentication, or MFA in short, has become widely popular in current time. Now it is supported by 98% of the organizations worldwide, and nearly 2/3 of the individual users now rely on it. Among MFA providers, Duo two-factor authentication app, or Duo 2FA, as we will be referring to it, is one of the most popular one. It is widely deployed across large enterprises, major universities, and Fortune 500 companies. However, despite its wide adoption, there is research gap in the real-world performance overhead and usability of Duo. Current studies mainly focuses on the technical challenges and the user's perceptions during initial rollout of Duo. However, rollout period is transitional. Users are adapting to a new technology, and their perceptions at that time may not reflect long-time experience. Studies on other 2FA methods are also outdated. Those are conducted in 2017-18 when 2FA was a new technology. Moreover, none of these studies used system usability scale or SAS score to measure the usability of Duo. Okay. Our work addresses these gaps by making three main contributions. We perform a large-scale and real-world measurement of Duo overhead, a combined quantitative and qualitative analysis of Duo usability, and an analysis of Duo failures using both log files and user survey responses. So a quick refresher about MFA. It is a security mechanism that requires users to present two or more verification factors. 2FA is the most common form of MFA that combines two of these verification factors. Duo 2FA normally uses knowledge such as remembering username and password as the primary authentication and possession, such as having access to registered phone as the secondary authentication. Our study was conducted over 9 months during 2024-25 academic year. It ran on UCI ICS Jupyter Hub sign-in website. Our collected log data include information about 2,559 unique participants. We also conducted a post-study survey with 57 participants. This is the sign-in website that was used for the primary authentication. Then Duo app was used for secondary authentication. Most of the users had to approve a Duo push notification task for the secondary authentication. However, some participants had to open Duo app and obtain a one-time generated passcode from there. Then they had to add that passcode after their password in the sign-in website. So approving the push notification is referred to as push notification task from now on, and adding the passcode to the password is referred to as the code input task. So let's quickly go over the results and analysis of them. We define Duo push overhead as the time between successful primary authentication and successful Duo authentication. Here I would like to mention that since Duo passcode was obtained and entered along with the password, we did not have a way to measure the time required to obtain that passcode from the log file. That's why we are able to measure only the push overhead. Duo push overhead distribution showed a long tail. This prompted us to exclude the outlier values after 95th percentile from our average calculation. After this exclusion, the average Duo overhead is 7.82 seconds. We observed statistically significant difference in Duo push overheads based on the time of day. There are two notable patterns here: an increasing pattern after midnight from 12 a.m. to 3 a.m. and an overall decreasing pattern during the day from 5 a.m. to 5 p.m. Push overhead is also influenced by participants' student level and academic measure. We observed statistically significant differences in overheads among graduate students and undergraduate students. Regarding academic measure, our participants came from 63 measures in total. Among them, 8 pairs show statistically significant difference in overheads. Out of these pairs, MCS consists of entirely graduate students. The other measures are mostly undergraduate students. So this effect of measure also signifies the effect of student level on overhead. We surveyed participants about their perceptions of Duo. They were asked separately about push notification task and code input task. For push notification task, the most common theme was positive emotion. On the other hand, responses about code input tasks are mostly negative. This is not surprising, considering that approving a push notification requires less time and effort than entering the code along with the password. From the log files, we observed that 4.35% of all the authentication attempts resulted in failure due to incomplete Duo task. This is significant considering that all of these attempts had already provided correct username and password. So primary authentication was already successful. The most frequent reason for failure was login timeout. In the survey response, 43.86% participants reported that they had experienced at least one Duo-related authentication failure during their usage time. And the most commonly reported failure reason was not having access to the registered phone. This aligns with our finding from here. Since users did not have access to their phone, the login timed out. We also asked users about their perception of Duo overhead. They are mostly okay with it. Very few participants thought that it took a long time to complete the Duo tasks. We also investigated Duo's impact on participants' sense of account security. Most participants felt that Duo app made their account more secure. We asked participants to rate 4 statements related to usability of Duo. Most participants thought that Duo was easy to use. However, they still found it very annoying. We used system usability scale to quantify Duo's usability. Duo obtained a SAS score of 70, which denotes good usability level. However, we did not see any correlation between SAS score and users' experienced overhead. There was also no correlation between SAS score and users' subjective usability perception. Like any other user studies, Duo has some limitations. I will not go over detail here since we are short of time, but you can look at the paper. Similarly, we provide several actionable recommendations to improve usability of Duo. The details are available in the paper. To summarize, our study answered 5 research questions about usability, users' perception, and overhead of Duo. Thank you, everyone, and I am happy to answer questions.
Yeah, it's not surprising to see most of the participants is from like USC and Helena's lab and everybody, right? So it's interesting. So yeah, please go ahead and ask.
Hi, I'm Barry Lebo from FutureWay. Can you flip back to near the beginning where you have the different factors? And the question I have is, how does that...
you mean this one?
Back one more. And just keep
okay.
going back.
The time after?
Back. No,
okay.
Keep going back. No.
Okay. Sorry.
There was one where you had the multi-factors.
Okay.
Okay.
This one?
Yes.
Okay.
So my question is, what factors were used to determine the usability aspects here?
So we do not use these factors directly to measure the usability. We use a survey method called system usability scale, and we also asked multiple choice and open-ended questions to users. These factors are used by typical MFA providers to provide the second factor authentication service. And for Duo, they use knowledge factor, that is primary authentication, and possession factor, that is having phone, for secondary authentication.
Okay, so the study was using just knowledge and possession.
Yes.
Okay. Because I question the security question bit as even being a second factor. But
Okay.
That's, anyway, you answered.
Okay.
I wanted to see if you have any insight about why graduate students, so you showed that there is some statistically significant difference in the length to complete the second factor between undergrads and
Yes.
Graduate students. Yeah, like, so just like on this table, do you have any insight to why it takes longer for graduate students?
So I have some rhetorical answer for that, that young people are more tech savvy, they are fast with technology. I don't have any insight from the research why it takes less time for freshmen compared to graduate students. That's what we observed.
Okay, thanks.
Yeah.
It might also be we take time to read more of these. But I have a quick question. My dissertation was on MFA authentication and everything. So it's been a while we have been doing usability studies on 2FA. In your research, as well as your experience, do you think now it's time to find like continuous authentication where we are taking less user inputs and making them, because they are still frustrated, and Duo is one of the most available and most used two-factor authentication, right?
Yes.
So do you have any insights into that? Like if there is any alternative to MFA usability issues?
Yeah, so I think now MFA also incorporate biometric. So in my experience, that has made the work a lot easier. So when I'm using laptop, I can still use Duo 2FA for Duo 2FA app, but I don't need having access to my phone. I can just use my fingerprint as the second factor authentication. And I think that is very helpful. And if somebody doesn't want to use their phone, then having a dedicated security key like YubiKey that they have with their keychain, that is also helpful.
Great. Thank you so much. Let's give a round of applause. So now we have a shift from authentication to LLM security, where Dr. Isha, who is a postdoctoral research associate in the School of Information Sciences, UIUC, and also a new joinee in fall 2026. She will be joining Rutgers iSchool. Congratulations again as an assistant professor tenure track. And they will be talking about the US privacy perceptions on LLM security. So over to you.
Thank you so much. You see the trees? All right, cool, amazing. But it's not my slide. This is PDF version. All right. Thank you so much for your attention and your time. Hopefully it's working. Okay. Today I'm going to talk about some LLM chatbots which you don't want to hear about it because you're super frustrated with LLM chatbots. So the paper is titled as From Awareness to Practice, a survey of US users' privacy perceptions in LLM chatbots. This was part of my dissertation back in Indiana University, Bloomington, and I'm very grateful to work with PhD students from Indiana University, Yuri Yan and Ege Ötenen. So I put some images that you don't want to see it, especially for the large language model chatbots, also how they're affected to data security, as well as the harmful effect for the specific individuals, including teenage and suicide. And there are lots of regulatory complications and political effects that is governing these AI harms and risks to the individuals. There are lots of regulatory compliance, like the risk that is composing to the United States citizens where they're using the LLM chatbots. So therefore, like, we basically wanted to investigate specifically how US users are pursuing their privacy in LLM chatbots. So we asked to what extent do US LLM chatbot users read privacy policies and how transparent do they find them? And how do LLM chatbot privacy practices influence US LLM chatbot users' perceived privacy concerns and potential risks? And then we also asked like how they exercise their control over privacy preferences, specifically looking at their privacy settings and how they manage and control their privacy. And we asked like how comfortable are US LLM chatbot users to disclose personal data when interacting with LLM chatbots, specifically how they perceive the sensitivity of personal data because they're, like large language models are collecting more data to train itself, and then it basically imposes and storage, which is kind of a black box in the training. And so how US users are basically treating the personal data as a sensitivity when they're interacting with these large language model chatbots. So we basically empirically developed a within subject online survey via Qualtrics, and we basically helped by the prior work within specifically addressing the research questions, reading privacy policies, perceived privacy concerns and potential risk, exercise control over privacy preferences, comfort of disclosing personal data, as well as back in like IoT devices, we basically look at the Lori Krainer's work on the sensitivity of information, or as well as the preference-based information. We used 5 Likert scale and multiple choice. We had conducted pilot studies, and most importantly, this survey included many researchers from the diverse disciplines from law, which is I'm in, security and privacy, HCI, and statistics, as well as the information science. We also, this study is very important because we also look at the multiple diverse of demographic information from the participants, as well as how their experience is influencing these privacy behaviors. So we basically recruited participants via convenience sampling approach. We just, we asked colleagues, friends, so we can basically distribute it and understand how the population are basically getting and perceiving their privacy in LLM chatbots. Also, we distributed popular social media platforms, including X, LinkedIn. We primarily looked at the, unfortunately, adults. It's not super related with the keynote, but we looked at the United States and proficient in English and prior experience with text-based LLM chatbots. Successfully, 267 participants completed the survey, and you can see differences between U.S. census, which there's no sexual orientation or any kind of technical literacy on the digital experience in the U.S. census. For the data analysis, we basically reported in descriptive statistic as well as we quantified effects of demographics, which includes age, gender, sexual orientation, prior chatbot experience, length of use, confidence, and daily interaction frequency on user perceived privacy-related behavior and perceptions by using GLM. And we basically treated the 5-point Likert scales as a continuous dependent variables and personal data types as categorical, and we dummy coded and predicted significance was evaluated using Wald test and within the 95% of confidence intervals, computing for all coefficients. We used the R for the quantitative analysis. Also, the survey included the free text responses, which we adopted thematical analysis, which included 2 coders, and there's an intercoder reliability through the Koha and Kappa. So for the perceived privacy policy awareness, I'm sure you haven't, you didn't get any super excited about this thing because it's basically common and nothing has been changing. There's low awareness of perceived informatives of policies among the LLM chatbots, and there's no low awareness of self-reported reading of privacy policies among the US LLM chatbot users. And there's also significant user effects on the demographic effects. Males reported higher scores in perceived privacy informativeness than females. And for the technical experience, we found out participants who used chatbot multiple times per day and with 1 to 3 years of technical experience had higher perceived informativeness of privacy. And we also found some moderate perception of privacy protection among the United States LLM chatbot users, which basically shows about they are not super aware of the understanding of the privacy risk in the LLM chatbots, and general disagreements on the personal data handling practices among the third-party platforms. We also found that the LGBTQ participants reported lower risk of perceptions than heterosexual participants, and age between 35 and 44 and plus 55 reported lower risk than those age 18 and 24. As well as the less than 6 months of technical experience reported higher risk than those with 1 to 3 years, and multiple daily uses and once per day use were associated with elevated privacy risks. And we asked how likely are you to review or adjust your privacy settings related to LLM chatbot after concluding the conversation. Most of the users were uncertain about their reviewing their privacy settings in LLM chatbots. There might be a usability issue. They're not even concerning whether they're effective or not, but they're not certain about it. We also found no significant effect on the demographics here, so everyone is kind of uncertain, and we found out multiple times per day users reported higher likelihood of adjusting privacy settings, and once per day showed elevated likelihood of the privacy control practices. We also asked how comfortable are you sharing personal information with LLM chatbots, overall discomfort of sharing personal data, and some significant user effects on the technical experience. As you can see, if you're more than 3 years experience with the LLM chatbots, you have lower comfort of privacy. And if there is any frequency of usage, usage of the LLM chatbots show higher comfort effects as well. And then we also looked at the specific personal data types, which includes the regulatory effects of personal identifiable information, as well as some most non-sensitive information among the US LLM chatbot users. They were mostly cautious about the sensitive data, especially credit cards, social security numbers, and phone numbers, but more willing to share preferences and relationship-based information. In the paper, we also, show the demographics and the technical experience effect of the perceived personal data types. Specific LGBTQ+ show the significant effect, and the gender male, and the age between 25, 34, and 35, and 45 to 54, and age 55, as well as the technical experience show the significant effect of understanding perceived personal data among the LLM chatbots. As you can see, there's some consistent privacy concerns about higher user vulnerability among the LLM chatbots, especially in the United States, where there's no regulatory reform governing these privacy harms and risks. There's some US LLM chatbot users may recognize risk but remain unsure or unaware of how to protect themselves effectively. There's a literacy and familiarity effects, which usable privacy and security needs to focus on this effect as well, rather than demographic effects, but also the literacy effects also influencing the user perceived privacy. And we shouldn't basically solely define usable privacy security among the personal identifiable information defined in the regulations. We need to basically focus on the process and connect diverse data types in ways traditional web services cannot do. As risk can arise continuously, our recommendations, we included the privacy tech and policy governance, which you can see it we basically highlighted the time and manipulation sensitive policy mechanism for both end users and the organizations. You can find more details about the paper and the proceedings, and thank you so much.
So while we are warming up, I can ask the first question. So given that recently there have been a lot of uproar on OpenAI's privacy policies, they have been sending emails, getting consent, etc., right, the entire spiel. Do you see if it is replicated, now there would be some differences because there has been some ongoing discussions about it, about LLMs, chatbots?
Right, that's a great question. Unfortunately, OpenAI is basically dominating the market of large language model chatbots, but LLM chatbot users are basically using other third parties. So it's not specific OpenAI's privacy policies are basically influencing and governing all the other platforms. So I'm basically like aware of this, but I'm not sure like how OpenAI's privacy policies are very transparent and informing the users, especially if we're basically discussing about the usability of privacy, and there's no specific such usability on the understanding and informativeness of privacy policies. And I don't see an OpenAI's like, work on how to inform users about their privacy. Does that?
Yeah.
Okay.
Hello, nice presentation. And so my question is, so I read a paper like last year, I think at PETS, that did something very similar to, I don't know if you're
That
aware
was
of
UK based.
Exactly.
So privacy is basically some cultural and different by the demographic. So we conducted the US version.
Okay, so my question to you is, do you have like an insight on the difference between the US perception versus the UK perception?
Oh, that's a great question. So like there's obviously like the informative path of the UK's, like before, especially like they were adopted the GDPR and then they informed the UK GDPR. So that definitely influenced their like specifically, like demographic population. Also like there's no significant effect on the demographic background. But here we can see exactly the same thing as the traditional web services, like the usable privacy studies confirmed. So that is the most important part. Also, like they didn't look at specifically the other demographic factors, including the sexual orientation, as well as the technical experience. I think that is the most important contribution to this field, besides the Malki et al. At Puppets 2025. Yes.
Thank you.
Yeah, and kind of piggybacking on what Pithayuth mentioned, I feel like this study can also be very interesting results with like the weird population in general, because because you mentioned about sexual orientation, and I'm quite sure there have been several studies which has looked into how this can be very distinct. My other question is, there are some policy-based tools which are available both in academia and industry, Policy Pulse, Policies, etc., right? So do you think those kind of classifiers, sentence level or paragraph level classifiers, can help enhance the perception? I was a little disappointed seeing the male versus female results, but yeah, anyways.
Yeah, I'm also like the very feminist part of this field, but yeah, I don't like that perspective. Unfortunately, that's the literacy problem and the cultural educational problem. So like for your question, we are basically working on governing knowledge commons and contextual integrity, which basically puts the specific keywording in like the policies and governance aspect, which influence the like organizational and governance structures. It's not about the users, but also like the developers and the organization settings. I think governing knowledge commons and contextual integrity is part of the policy making that could increase at least the usability in these things. Also, like the most important part of the policies are, it's not time aware, and it's not even looking at the time decision making. And I think we need to focus on more time and context aware systems.
Absolutely. Thank you so much. Let's give a warm round of applause. I realized I have not introduced myself. Hi, everybody. I'm Charnsethikul. I'm an assistant professor at George Mason University. And our next presenter, unfortunately, is online, but they will be joining for the Q&A session as well. And yes. So Mete Harun Ake is a second-year master's student in computer science at Abo Academy University. His research focuses on AI applications, particularly LLMs, computer vision, and trustworthy AI. This paper resulted from an internship at Nokia Bell Labs at Finland, and it is about visual privacy. So I would request the AV team to please play the video. and their advisor would be
This is
available for.
Nakchai, and today I will present our paper, More Than Meets the Eye, Understanding the Effect of Individual Objects on Perceived Visual Privacy. This work was conducted in collaboration with Sidro, Alex Bakas, and Busatle at Nokia Bell Labs. Let me start with a simple example. At first glance, it looks like an ordinary photo taken in a public setting, nothing obviously sensitive. But if this image were shared online, what does it actually reveal? Well, actually it reveals a lot. We see the date and photographer's name, an identifiable face in the foreground, and additional faces in the background. We can estimate demographic attributes and even make guesses about the location based on visual cues. So visual cues enable rich contextual inference, which can unintentionally expose sensitive information and lead to privacy harm. The question is how people evaluate these cues when deciding whether to share an image. Existing work in this topic either classifies entire images as public or private, or focuses on individual objects independently by ignoring interactions between the objects and the context of the image. Our objective in this work was to understand how individual objects, context, and their combinations shape perceived visual privacy. As our contributions, we offer novel insights into how people evaluate visual privacy and the factors shaping their perceptions. We provide empirical evidence on users' privacy perceptions from a survey. Finally, we explore synthetic images as a controlled and practical alternative for visual privacy user studies. To study this systematically, we introduce a simple conceptual framework. We define a privacy-sensitive object, or PSO, as any element in an image that may carry privacy risk. A foreground PSO is the primary PSO, here the person's face. Background PSOs are additional sensitive objects co-present in the image, such as the medicine bottle or the tattoo here. We also consider the environment, which refers to the broader context in which the image is captured, in this case a cafe setting. To measure perception, we use comfortability level, which reflects participants' willingness to share the image. Finally, perceived privacy level, or PPL, captures how privacy sensitive the image is perceived to be, and it is inversely related to comfortability. So we formulate these three hypotheses. First, we say that PPL of a foreground PSO increases when it is accompanied by a background PSO, which we test by comparing ratings of foreground-only images with foreground plus background images. Second, we hypothesize that the surrounding visual scene affects the PPL of the same PSOs, so we compare identical object combinations across cafe and office environments. And third, we hypothesize that the co-presence of multiple background PSOs further elevates PPL compared to a single background object, which we test by comparing single background images with images where two background objects appear together. So we conducted an online mixed method study with 109 participants, retaining 92 valid responses after filtering. Our experimental factors included 3 foreground PSOs, face, miscellaneous paper, and computer or phone screen, each paired with 5 predefined background PSOs evaluated in 2 environments, cafe and office. For analysis, we applied statistical testing, percentage-based analysis, and thematic clustering of qualitative responses. The survey begins with 12 demographic and general privacy questions. Then, for each foreground, participants follow the same procedure. They first rate an image with only the foreground on a 1 to 5 Likert scale. Next, they see 5 images where the foreground is paired with each background PSO and update their comfort level. Then they rank them and briefly explain their rankings. And using a branching step, the background object rated as most comfortable is kept constant, and participants rate 4 new combinations with the remaining background objects to examine co-presence. And this process is repeated for all 3 foregrounds, and in total, each participant rates 30 images and answers 48 questions. If you look at the results for H1, in these graphs, the first bars show the mean comfortability level for foreground PSOs only, while the rest are the comfortability levels of combinations of foreground and background PSOs. we observe almost all background PSOs decrease comfortability levels, meaning they increase PPLs. And here we underline the background PSOs which have statistically significant change, so we can regard them as more private objects. For H2, we compare distributions of the images of same PSOs from different environments. Overall, the same objects are consistently regarded as more private in the office environment compared to the cafe. The table here shows only the statistically significant differences, such as an image that has a birth date on a paper is regarded as more private than an image with the same paper and birth date, but when it is at a cafe. For H3, we see when two background objects appear together, they can either amplify each other, which we call co-presence effect, or one can dominate the other. The tables here show the top 4 co-presence pairs for each foreground. The percentage indicates how many participants rated the combined image as less comfortable than each object alone. For example, nearly 40% of the people rated face with poster and tattoo as less comfortable than face with poster or face with tattoo individually. We observe similar amplification patterns across all the 3 foregrounds. The next table shows the dominance effect. The percentage indicates how often one background object determined the rating even when another object was present. For instance, medicine dominates about 65% of its combinations for the face foreground. For paper, address is the most dominant, and for screen, username shows the strongest dominance. From the qualitative responses, we identified 3 main themes and their sub-themes. First, perceived privacy norms, where users rely on social expectations and consent. Second, inference and linkability, where they worry about combining cues to infer identity, location, or other sensitive information. Third, irreversible harms, where they concern on long-term risks, stigma, and potential misuse. So to conclude, we show that the perceived privacy level is shaped by the background objects, the environment, and the interaction between multiple objects. We also find that users apply layered reasoning, combining social norms, inference risks, and possible future consequences when making sharing decisions. Overall, these findings can guide the design of object-aware and context-sensitive privacy systems, especially for assistive technologies and visual content sharing platforms. So that was all, and thank you for your attention.
So do we have the present for the Q&A? Buse? Oh, yes. Yes. Hi. So while we are prepping on the questions, right, I feel that it's very interesting to look into these visual privacy concepts. And you did use synthetic images to do the tests, right? So do you think if there were real images, of course, for obvious reasons it was not used, it would generate different emotion amongst the participants you have analyzed? And in addition to that, the order of the images, right, does that make any difference?
So first, for the synthetic versus real-world images, so it was not just because of the privacy reasons, it was also in our test it would be really hard to keep everything constant and change only single thing. So we had to come up with an intelligent solution, and that's also another reason we use the synthetic images. But this brain stimuli people might change their answer when they see, for example, themselves as the foreground object. But right now, I mean, we generated these images last summer 2025, like spring 2025. But even in the short term, the SORA is improved so much that now we can't differentiate whether this image is synthetic or not. I think right now we kind of close the gap, and when a human sees a synthetic image right now, they might simulate their answers for the real images as well. For the order, you mean the order for the background objects.
Yeah, the order on which, because you have shown the same image in different styles as well as rotations as well. So do you think how it is ordered also matters in this perception?
No, we didn't do the different sizes. The image size is the same, the rotation is the same, the lighting is the same. It's just the order of background objects changing. But I don't think so, because it's still random. You know, you still have the foreground object, it doesn't change, and the only background things is changed. So I don't think it would affect the answer.
And finally, does this imply that privacy nudges and warnings should become contextual and compositional rather than just binary or object-centric?
Yeah, that was the whole result from the biggest result from our paper. It's not the privacy for image, privacy for input, but it's the nuances and contextual cues that makes that can change the privacy of each pixel. Even it's really we have to think about fine granularity.
Agreed. And one last thing which I have, I'm quite sure I'm reiterating things which we are all thinking in the room, which I don't know whether you can see us, but we can see you. The next is, you mentioned about very particular topics such as tattoos or medicine bottles and everything, which is very specific sometimes to individual people. So very great objects, by the way. But do you know if the subject of the tattoo or the type of medicine, it was visible? That made any difference? Because there have been studies on self-representation of privacy. So did you see any difference, or do you think in the future work you will like to switch between the topics to see the difference?
I didn't get the question.
If a tattoo is of a butterfly versus maybe supporting a group which is not really universally approved, right? So the topic, does that matter?
Yeah. I mean, we didn't check that. We checked like a tattoo that doesn't relate to any opinion. But I think we added this, in our discussion, we added something like, it's not specific to tattoo, but other contextual cues relating personal opinion on something, a political opinion, something like that. These are not objects, like in the definition of an object, but they are also contextual cues. If you check the photo we shared in the presentation, it's also in the paper. There are a lot of contextual cues that are not present in the image, but it's kind of, I think we made a successful prediction of where the photo was taken based on the skateboarding and young people demographic in the US. So it affects, the result it affects. Definitely we should check many different things.
Of course. We wish we can see you next year in the conference, but thank you so much for joining us. And yeah, let's give a big round of applause. Do we have our next presenter here? Yes. So now from authentication to chatbots to now crypto wallets is our next topic of research. So Lily, who is a first-year PhD student at Carnegie Mellon University in the Societal Computing program, will be talking about it.
Thank you for the introduction. So I am Lily Klusenik, as was mentioned, and I'm here on behalf of my colleagues at Carnegie Mellon University, talking about our paper about emerging adults' experiences with crypto assets as teens. I'll get to the quote that's the first part of our title later on. So reports indicate that young adults are increasingly using cryptocurrency assets. For example, there was a 2023 report from FINRA that showed that crypto assets were the most popular type of investment for people ages 18 to 25 in their survey. And around 25% of people who indicated that they invested in crypto assets said that they used crypto before turning 18. And previous work analyzing Reddit posts indicated that teenagers experience similar crypto harms to adults. So one of my collaborators on this paper previously studied almost 1,700 crypto-related posts on various subreddits and found that teenagers experience many different types of losses. These are primarily financial losses due to investments, scams, wallet or key loss, etc. And this work is basically what inspired us to kind of get a more direct and rich understanding of teenagers' cryptocurrency experiences using a survey-based approach, also maybe to capture people who didn't want to share their experiences online or on social media, things like that. So to answer this, we asked the following research questions. First, we wanted to know how teenage users gained access to the crypto asset ecosystem. Secondly, we wanted to know what motivated teenagers to acquire cryptocurrency assets. Third, we wanted to focus on the security and privacy issues teenagers faced when using crypto assets. And finally, what negative and also positive effects teenagers experienced when using crypto assets. So to do this, we surveyed 143 what we call emerging adults. These are people aged 18 to 20 as defined in our survey. There were both ethical and practical restraints on this, so we didn't want to survey teenagers who were actively using crypto because that's usually against platforms' terms of service and might even be against laws in some places. Also, for practicality reasons, it's just much easier to recruit people who are over 18 and not have to get parental consent for them who might also not even know that their kids are using crypto assets. So we utilized both university mailing lists and Prolific for online crowdsourcing. We also reached out to cryptocurrency organizations at many large universities across the country and utilized our professors' connections to other professors throughout the country as well to distribute our survey. We only received responses from 11 of the 77 universities that we contacted on our own, so relying on faculty connections was actually much more reliable than trying to reach out to student organizations directly. And in our survey, we basically asked participants to share their experiences with 4 main types of cryptocurrency assets. So that's traditional cryptocurrency, cryptocurrency derivatives, NFTs, and then we also allowed participants to describe any other assets that they interacted with that didn't fall into one of those 3 categories. So first, let's look at how teens access the crypto ecosystem. So most participants claimed to own crypto assets in their own name as teenagers. That was 62 participants out of our survey across both cryptocurrency and NFT users. However, most exchanges don't actually allow minors to do this. So unfortunately, people either misunderstood the question or did something bad that we didn't have any follow-up to ask them about, unfortunately. So we're not entirely sure how this happened. 10 of the participants who did do this, though, used Binance, which was actually charged with avoiding KYC, I believe, back in 2023. So this is concerning because they were able to dodge very important practices when accessing cryptocurrency. Now moving into motivations for utilizing crypto assets. So probably, as most people would expect, profit was the most common reason. We had 40 of our 143 participants say that that was their motivation for buying crypto. An example quote of this is, "My friend in middle school made a couple $100 from it, so I decided to join him and make some quick money from day trading cheap cryptos." Secondly, participants wanted to gain financial independence, and this is where that whole their parents might not know they're using crypto comes in. We had 25 participants who said that they wanted to be able to use cryptocurrencies to buy things on their own, or maybe if they weren't able to get a job. For example, this participant, and this was probably the most wholesome quote we found in our entire paper, was, "My mother's birthday was coming up and I had no money, so I found a way to convert the Bitcoin that I had been mining to an Amazon gift card via BitPay." And this participant further went on to share that they bought something their mother really wanted, and that was the most wholesome thing we saw. We saw also 20 mentions of peer pressure or parental influence. So half of these were from friends. For example, someone said that they used a sketchy online exchange that their friend recommended and actually ended up getting scammed from it. But something else that was interesting was that 6 of the people who peer pressured or influenced the teenagers to gain crypto or buy crypto assets were fathers. And we actually found pretty much negative experiences only with this, with one participant saying that it was very stressful and demanding to me, as at that time I had little to no idea of the outcome of the numerous transactions my dad requested me to make. And this was a major finding of our paper, that parental influence, particularly fathers who influence their kids to do this, basically led to the teenagers being very stressed. And then finally, we had 17 participants who mentioned wanting to learn about financial markets. This was just ranged from pure curiosity to some people really wanting to get to know the nitty-gritty of various exchanges. So third, let's look at the security and privacy issues experienced by teenagers. So the most common negative experience security-wise was wallet or key loss. 34 of our users, or our participants, said that this happened to them. For example, some participants didn't think to write down their keys or store their keys in multiple places. So for example, this participant lost their key in their broken phone. Others lost them when they updated their computers and lost information, things like that. Secondly, we had participants who experienced what are called pump and dump scams or rug pulls. For those who don't know, a pump and dump scam is when a coin is artificially inflated, that's the pump, and then a bunch of people who are in on the scam sell it for a lot of money, and then the price of the coin or the value of the coin basically severely drops, hence the dump part. So for example, the quote on the screen is a participant who got rug pulled, where they bought a SPL SOL token on Dex Screener with the hope of making profit and got rugged. Rug pull is also basically just they think something good is going to happen and the rug gets pulled from underneath them and they end up not making money or losing money. We also had 17 participants who said that they experienced hacking when using crypto assets. For example, this participant said that they connected their wallet to the DEX exchange and they found all of their assets to be emptied. Unfortunately, they didn't provide further information than this, so we don't know exactly how they got hacked, but they shared a hacking experience. And finally, there were other types of scams that participants experienced that weren't pump and dump scams or rug pulls. For example, hence the title of the paper, I wanted to buy Robux but got scammed for $10 in Bitcoin I bought on Coinbase by some stranger on Discord. Finally, I'll go into the both harmful and positive outcomes of crypto asset usage. So for the negatives, most participants, the most common experience was monetary or financial losses. This was from a few cents to what some participants said were their life savings, which were around $2,000. We also saw a lot of teenagers who experienced emotional impacts from losses. This is both due to real and hypothetical losses. So for example, maybe they didn't actually lose money, but the value of the coin fluctuated and that made them have an emotional reaction. We saw that the emotional impacts due to losses were similar to those who experienced gambling losses in our paper. For example, a participant who was watching the value of a coin fluctuate said that they obsessed over the prices and didn't do classwork, instead focusing on just watching the price rise and fall. On the positive aspect, teens experience both profit and financial independence. For example, this participant said they made $2,500 and felt like John Rockefeller because of their positive experience. Some participants shared both social and learning experiences, just simply saying this was a positive experience because I spent a lot of time with my buddy. Some participants even reported improved technical skills. This was mainly for those who maybe mined crypto on their own, but this participant said, I got access to devices that could passively run a Monero miner in the background and made about 7 of them do so. And finally, we had a few participants, only about 3, mention the positive aspects of privacy or anonymity of using crypto assets instead of regular financial exchanges, with this participant pointing out that it's centralized and anonymous, so your transactions are completely private to the outsiders, regardless of whether or not that's true. So in conclusion, we confirmed findings from Bomasims et al., the Reddit paper, regarding how teenagers access crypto and their motivations for doing so. We observed the various risks that teenage crypto asset holders are exposed to, such as pump and dump scams. And we found evidence of the emotional or mental harms of losses that were not found in previous research. Thank you so much for your attention, and I'm happy to take any questions.
Yeah, please go ahead.
This is Barry Lieba from FutureWay. I have just an idle question about a non-core piece of this, the dad pressure. Yeah. What's that about? Were the dads looking to teach the kids something, or did they want them to do something that the dads didn't know how to do themselves? Or where did that come from? What were they trying to do?
So it was actually kind of a bit of both. So we did see a few fathers who didn't have the experience, like the tech experience on their own to do things. And so they said, hey, child, can you do this? Or can you learn how to do this for me? Some fathers, I think, might have also done it to, like, because they wanted to teach their kids something initially, but then as the quote that I showed said, it was like, you know, very stressful for the teenager to put a lot of pressure on them at the time. So we're not exactly sure like what the original intentions were, unfortunately. I think we would have loved to have been able to follow up more about that, because we did see like a non-trivial number of fathers put pressure on their children, basically. But unfortunately, that's about all that I know.
Yeah, it wasn't a core piece of your research there, so thanks.
Of course.
Hi, thank you so much for this nice study. I have a quick question. You mentioned that most crypto exchanges like Binance don't allow minors. So I was curious, do they enforce this with real age verification? And are you aware of any methods that they use?
So from what I understand, a lot of the crypto exchanges did use some form of age verification, so we're not actually sure how people claimed to get things in their own name. I believe Binance was mentioned because they avoided KYC practices, so I think in 2023 they were charged with that, so they might have KYC practices now, or they might not exist, I'm not sure. But I think that the next most common thing that people did was they had their parents buy it, or like an older relative or someone buy something in their name, but have the teenager actually use it. So that's one way that people circumvent that. I hope that answers your question.
Yeah, it answers. Great, thank you.
Yes, I have a quick question. You mentioned, oh my goodness, mentioned about the recruitment strategies and everything, right? So I'm assuming like all the people in the network are also pretty tech savvy. So, and given the nature of cryptos and everything, do you think that sampling bias had an impact on the results here?
It probably did, because even when we recruited on Prolific, we did have a screening survey that talked about crypto, so people probably like did self-select into it and did probably bias the results. We did want to focus specifically on people who did actually own crypto as teenagers, which, as far as I know, is a very difficult group to recruit. So I'm not sure that if we had just done a wider sample, we would be able to get as many people who experienced that. But there definitely could be bias in this.
Of course, yeah.
All right, thanks for this, for telling us how to become a crypto bro. For a more serious thing, I think high schools in the US, or ones that do it, have financial independence classes. And also there is a huge push to have cybersecurity as alongside that kind of classes. In your opinion, since the word crypto floats around and adults don't know half the time what it means, and this is a very much a nascent population that could use a combined learning of what crypto means, what cryptocurrency means, what scam means. Would this be a fitting one, 2-3 birds with one crypto scone? From educational perspective, like harms and all that, but I'm just more so thinking on a longer term, We certainly, to our keynote speech, we certainly cannot stop everything from happening. Kids would want to be crypto bros, but how will we have to make sure that that's not necessarily out of control?
Yeah, I think so. Something that I didn't discuss in the presentation, but that we cover in the paper, is that teenagers are also influenced a lot by online influencers who talk about cryptocurrency as well. So it's definitely not something that's going to go away. I haven't been in high school myself for about 8 years now, so I don't know if things have changed, but I know that financial education was not a requirement for me to graduate. So I think even having a financial education class be a requirement is still something that we're working on, but I do think that including information about cryptocurrency is important just because it's not something that's going to go away. It's talked a lot about on social media, especially by influencers that a lot of kids watch. Like in the paper, we specifically point out like Mr. Beast talks about crypto and has run crypto promotions. So, I mean, children watch that. So they're going to know about it, and I agree that they do need to be educated about it.
Okay. All right. And also one last thing on your opinion.
We might have to take this question offline. But again, thank you so much. I just had a reality check myself that the emerging adults have better financial maturity than me. So that's really fun. But thank you again. Let's give a warm round of applause to Lily. So from my reality check to next is the new reality. So the next presentation is on virtual reality by Jenny, who is a fourth-year PhD student at DePaul University.
So as Sanchari introduced, I'm Jenny Vanderloop, and this was a collaborative work with LMU and DePaul University. So VR headsets are starting to advertise themselves as, sorry, is that better? Okay, perfect, thank you very much. Are starting to advertise themselves as productivity tools, so being able to use them in a workplace setting. And what we're finding is that companies are actually starting to do this. They're using them for training, and they're using them as part of their hiring practices, and they're starting to bring their employees into these virtual environments more often as a way to have collaborative meetings and such. But the problem with this is employees spend a massive amount of time checking their emails during the day, and putting them in virtual reality headsets and immersive environments isn't going to change that. They're still going to have those expectations of having to check their emails and participate in regular work environments. So what we were really asking is what happens when these environments start meeting phishing emails and start being exposed to suspicious emails while you're in that immersive environment. So our questions were, how do users assess suspicious emails? What effect do they have on users' actions within them, and what kind of recommendations do users have when it comes to these immersive environments, in the warning banners and in the environments themselves? All right. So how we did our study is we recruited our participants. We had 40 participants total, and we had the Apple Vision Pro and a MetaQuest 3 headset option. We had them come in one-on-one, and each of them used the headsets. We had them assigned to one or the other, and they checked their email. So the Apple Vision Pro has a built-in app where they can check their email through the app, versus the MetaQuest where they checked it through their Gmail account. And then once they were in the environment, we sent them an email. It was a suspicious email that we were hoping that got flagged by their email account. And it was one of two. It either had an attachment to it or it had a link to it. The link took them to our research lab's website. The attachment was a blank email document. But both of them were likely to get a warning banner on them, so that way it went to their spam folder. And we had the users go out to their spam folders and check the first few spam items and tell us about what they were seeing out there while they were in the virtual reality environments. What we found is people actually got a variety of different experiences based on their email settings and prior interactions with spam. So they didn't all necessarily get the same warning banners, and they didn't all have the same experience. So some of them got the red one that said that this is dangerous, others got the yellow cautionary message, and some got this gray message, so much less bright and noticeable than that red one. Some got no warning message at all, and that happens because maybe they had interacted with AWS in the past or something like that. Prior interactions with those types of emails may have caused that. So what we found was that 2 of our users actually ended up clicking that link while they were going through their email unintentionally, and 1 opened that attachment. Again, they weren't truly malicious or anything like that, so there was no actual harm when they clicked those. But when we talked to the users about what they were experiencing, a lot of them said that they were having trouble because the links were, or the controllers were too sensitive. It was hard to click precisely. It was hard to narrow down what you were intending on clicking on, and you may accidentally click. So our one that opened the attachment accidentally opened the attachment in the process of assessing whether or not the email was legitimate. We also found that because of the immersive environment, people were having trouble with the multitasking and with the fact that the one did not have an email app. As you could see in the original pictures and the pictures there within the paper, you can see through the apps. So there's a lot going on. You can see the world around you, you can see the apps, and you can see anything else you have open and anything else you're doing as well, which can create this environment where deciphering something intentionally is really difficult. There's so much coming at you, and our participants all noted that as well. So we took a look at what kind of actions they were taking with those emails that we sent them, and we found that most people ignored them, ignored phishing emails, which is great. We had some that investigated them and saw whether or not they were phishing, and then others that chose to unsubscribe from our phishing emails or delete them. A few people reported them or blocked them as well. Throughout this process, we noticed that there's the opportunity for these deceptive patterns within virtual reality headsets. So it created an adverse effect on user experience by being in that virtual environment. It also exacerbated the chances that somebody was going to be manipulated by a phishing email. Users had a more realistic environment, and you could create a more hyper-personalized scenario within that environment that would then allow phishing emails to seem even more real than if they were just in your standard inbox, because you're in that immersive virtual reality environment. So we did come up with some design proposals. We asked the users for their suggestions and came up with some ideas there. The users in our participant study said that they would love to see better color coding. So we talked about, you had the 3 color choices, you had red, yellow, or gray. They wanted to see more color and more alternatives to the color, maybe some green to tell you something safe, or something brighter that comes at you a little bit more. They wanted more algorithmic control over that as well. So not everybody felt that they were getting those warning messages in the right places, and some people weren't getting them at all. The content of the message, some people didn't feel was incredibly descriptive, and people felt like it could have the opportunity to pop up a little bit more, be a little bit more noticeable than just the standard warning, because you are in that environment where there's so much coming at you all at once. And then some of our users wanted a risk indicator, something that told you how dangerous the email really was, rather than just it is or it isn't. So we came up with some ideas for solutions based on some prior work that had been done. We thought about some 3D designs. So here are our 2 proposed solutions. The one is a 3D pop-up, and the other one is a little less 3-dimensional, but still has the glow outline around it. And with that pop-up, then you would have the ability to have a bigger action button and be able to have more control over what you're doing when you're interacting with it. Also, the use of auditory feedback, such as a beep or a tone to let you know you're about to interact with a suspicious email, would be helpful. And then, so making it not only pop up, but also be bigger, larger, and glowing would help a lot. And then while we're doing all of those things, still maintaining those standard message warnings that people are used to seeing, like exclamation points and stop signs. So not changing that element of it. All right. So thank you so much. Does anybody have any questions?
Great.
Hi, thank you so much for the great talk. So I have one question. Like I saw you did the user study in terms of when you were finding the risks in VR, but did you do any user study after you find the solutions and how the users are actually doing with this new design? And like, because you said that the clicking was one of the problem. So with the new solution, I am curious if the clicking problem was solved.
We haven't, but that would be fantastic to be able to do. So we would love to actually do that and implement them and see if people are experiencing less problems with the clicking, because it is bigger and brighter and easier to get to, but we have not yet. So.
Okay, thank you so much. Thank you.
Yeah, thank you.
And I had a quick question, because you definitely showed that one size does not fit all, right? The security models does not fit for the immersive environment. But what about multi-device, multimodal interaction where nowadays users are switching on and off between the apps with the VR devices and so on? So how do we find a balance in that case?
Yeah, absolutely. So we experienced some of that while we were doing the study, is because people have like multi-factor authentication and those types of things. So there was some going back and forth between devices, even just in the time frame of our study. What would really help is if both platforms had an app. So the app could actually have that customization. The Apple app made the ability to do something like that much easier than using that Gmail that was in the Meta environment. Meta doesn't yet have an app, but I could see that coming for sure. So that would help a ton.
Absolutely, and I think the design proposals, which the paper in detail says, I highly encourage to read that. I think that definitely clarifies it, and also it was interesting to see 2 people did click on the phishing links, right?
Yeah.
So that's definitely concerning. But let's give a warm round of applause to Jenny.
Thank you.
Thank you.